Hey guys, welcome back for another video. So huge disclaimer, this is definitely not going to be the only way you can do this stuff, and it's probably not even the best way, but right now, for some of these things, there aren't any instructions out there, so here we are. Just want to try to help you guys play with some new settings. Now, if you're just here for the new time alignment features that have been added to the beta version of REW, then you can skip to the timestamp shown on the screen right here. For everybody else, I'm going to quickly step through everything from start to finish. It's not going to be a complete walkthrough. You can look through my other video for all the nitty-gritty details, but this is going to show you some changes that I've been making, and I've been following some new procedures after playing around with everything, and I've got even better results from doing so. So here we go. First thing, I need to address something that I've seen a lot of people making a mistake on, and that is having your AVR in the wrong mode while you're trying to do these kinds of tests. For Yamaha, you want to be in what's called straight mode. If you're just coming into a default setting, you're probably going to be in auto surround decode. The problem there is it pulls in your surround speakers and center channel while you're trying to do sweeps through the mains. You need to be in what's called straight mode, which is basically stereo or two channel. All we're feeding from REW to the receiver is a left plus right two-channel stereo signal. That's all we want to be working with. The surround channels and the center channel speaker are not playing and never should be playing during any kind of room tests. So whatever that's called on your brand, if you don't have Yamaha, just make sure you're in that mode. A second, much more common mistake I see people making is having things at the wrong volume level on the AVR and the subs themselves. Now, unfortunately, you won't know if your subs are in the correct volume range. I'm talking about the volume or gain on the subs themselves and what's on your AVR as far as the sub level control relative to the mains until you do an AVR calibration and you find out. After you run a calibration through your AVR, you need to make sure that your mains levels are at 0. That means that everything else that it tested, all the other speakers, were within range of being able to be controlled, and it set the mains as the baseline at 0. That is what should happen. If your mains are being boosted or cut, that usually means your subwoofer is out of bounds. It's out of the range where it can be using the signals as is without having to try to cut or boost the mains. So for example, if your mains come back at plus 10 dB, that means it's trying to boost the volume of the mains and your subwoofer is way too loud. It's trying to match the volume of the subwoofer, and your subwoofer is probably negative, whatever the max is, and it's trying to cut that. That's a typical situation. A lot of people will get their subs and they'll crank the gain way too high during a test. During testing especially, the subwoofer level has to be low because it's trying to make a flat response. I know that's not what we all like, so we crank it up to what sounds good to us. Well, that's not good to testing. So make sure you start with your sub volume somewhere around its half point, and then let the AVR do its thing, and your mains should be set at 0 when it comes back. Conversely, if your mains are in the negative result, that means your subwoofer is too low, so you need to boost its gain a little bit. You'll have to go through this and get all the way to the end to see what happens to know if you're in the right range or not. But that's a very, very common mistake. Another hugely common mistake is testing at the wrong volume level. So what you need to do is when you fire up REW, pull up the SPL meter and pull up the generator. We want to generate pink noise. If you're just doing the subs, you can select sub calibration. If you happen to be testing your mains also, you can go to full range, but we're only interested in the subs and its crossover point, so we're just going to be using that. Set it to -12, that is the testing volume level, so we want it to be calibrated to that. Press play, and then what you're going to hear is the noise playing. Now, your AVR is going to be at some volume level, whatever it is. I have mine set to come on automatically at -38. You may have yours set to come on at whatever you turned it off at. So it's going to be an arbitrary number. The point is, you press play here, you're looking for this number to be somewhere between 75 and 80 dB. So turn up your AVR This is after you've set your AVR calibration and your correct sub levels, by the way. It doesn't matter what they're at. And just get this somewhere in that range. Anywhere in that range is good enough. There we go. That's around 76, 77. Boom, we're done. We can close that. All you have to do is now remember what volume your AVR is at. So I'm at -30. That's going to be my test AVR volume going forward. The problem with not getting this right is a lot of people will test with that way too loud. They'll be cranking that thing to listening volume. And then you get back your test results and it's pushing 110, 120 dB out of the subs on your charts. That doesn't work. Number one, the microphone is not calibrated to that level, so you're getting slightly inaccurate results. And number two, it's just putting way too much energy in the room to get a perfectly accurate result. Plus, your mains are not going to be at that level. If you're too low and you're testing, a lot of people are trying to test late at night and they don't want to wake up the house, so they turn it way down. The problem with that is you don't have enough signal coming through compared to the background noise in your room. So you're not getting really accurate results there either. 75 to 80 dB is the sweet spot for where you want to be to get the best signal to noise and the most accurate results throughout testing. Now, one change from the previous video is this is going to be using the current beta version of REW. This is going to be necessary for the new time alignment feature. It's only in the beta and you have to search for it. I just Googled REW beta download and it takes you to this page here. All of the downloads and discussion and help is on a third-party forum right here called AV Nirvana. And you can have both versions installed at the same time, like I do. So if you don't want to or need to run the beta for whatever reason, you still have all the old information. Now, the controls for all the basics are still there, but some things have shifted around. It's gonna give you the same results either way. However, this new version has a cool feature that will really save us some time getting the phase relationship between the sub or subs and your mains pretty much automatically. It's really cool. So I'm not going to run through everything real time. I've already done it, but I'm going to show you each step and the results. For the sake of this video, I'm here on a brand new blank config. So everything is blanked out in the MiniDSP. Everything is set to 0, nothing loaded. I've got everything blanked out in the SVS apps. After you run the Yamaha or Denon or Marantz or whatever calibration in your AVR, you do need to do a couple things. Now you can run this afterwards. You're just going to have to remember a bunch of settings and put them all back to what you find. I find it easier and faster to do the calibration first and then just blank everything out, and whatever it ends up at, you're done. It's just faster. In the EQ settings, you want to blank out the sub. Now in Yamahas, all you have to do is go to manual. You can import one of the results, such as front or natural or flat. I believe flat is the default. So I went to manual and I simply imported that and then went up to subwoofer and blanked everything out. I put 0 for all the gains, and that gives us no EQ applied to the subwoofer out. That's what we want. The other thing you need to do is in distance, you can leave it however it comes out of YPOW or Odyssey or whatever you're running. It's gonna change. It might be really close. It might be spot on. You never know. I started with mine very arbitrary, and I actually started at 12.4 just because that was one of my mains. And I'm gonna set it to that just so you can see exactly what this new feature does. I'll set it to 12.2 just so it's a little easier to remember, because I was at 35.2, which is my correct result. What this is doing is setting the phase. Phase, distance, delay, all the same thing. You can do it here in the AVR in a distance calibration. You can do it in the MiniDSP as a delay calibration, or you can do it in the sub app itself as a phase calibration. What I'm doing in the AVR is both subs at once. If you only have one sub, all three of those do the exact same thing. I have more than one sub and I want to affect them as a group, so I'm doing it here in the AVR. I could also do it under the input of the MiniDSP to do things through the MiniDSP, so you'll see me doing a few things in the SVS app and the AVR, but all of this could be done in MiniDSP. So what you'd have to do is on the individual outputs, add the delays down here, and you'd have to figure out exactly what they are, and then set them both the same. So at this point, my subs are working as one unit. They're both the same model, so I don't have to gain match. They've been level matched. They're in different spots in the rooms, and there is a 2 dB offset in volume or gain between them to get them to play at the same level. That's already done. I've got a single sub out coming from the AVR into the MiniDSP, then a separate output from the MiniDSP to each sub. So from this point forward in the video, I'm just going to call it the subwoofer because they're acting as one as far as the system is concerned. Testing sweeps need to be at full range. We are going to be testing from the sub through the mains to get the best crossover response. I'm starting at 10 and going to 20,000, again at the -12 volume. And here we go for the first run. Click all SPL up here to easily see what's going on. Now I do have the full data, and you can see it here. I'm only going to be showing 10 to 200 just because it's easier. Crossover point is set at 80 in the AVR right here. So what we're going to be looking for is a smooth transition in this area here. Now that already looks pretty darn good. But one thing you can see is the sub level is a bit higher than the mains level. We do want, for testing purposes, these to be fairly even. A good way to see that is to go to full range, 20 to 20,000. Just turn on some type of smoothing, 6, 12s, psychoacoustic, doesn't matter. What we're looking for is this right here. We can see that the sub level is higher than the average level. Now the average level here is shooting right about 70 dB, and subs are, about 7 or 8 higher than that. So what we need to do is turn down the volume on both subs equally to bring this down somewhere closer to this level. So in the SVS app, or if your sub has a gain knob on the back, turn them down equally, remembering if you have an offset to keep that in there. Let's test again and see if it's more even. And again, this is just to make sure that when we're matching the phase between the mains and the subs, we get an accurate result. And hit a little bit of smoothing. We'll go to 1.6. Okay, so there we can see a much closer level match. So this is what we're going to be at just for testing. Later on, we can bump that up to taste. That is to personal preference, what your sub volume is at. But for testing, we need this to be even as possible to get accurate results at the crossover point, which is right here. So going back to 10 to 200 and turning off smoothing, we always want to work without any smoothing as far as the subs are concerned, so that we can see every little tiny problem that we have to deal with. So at this point, what we need to do is start EQing. We want to get this response, all these peaks and valleys, as flat and level as possible. Doesn't really matter what type of slope we're going for, if we are looking for a straight line or if we're looking for a slanted line. We just want to get rid of all this variation and we want it to hug some type of line. So we're going to go up into EQ, and again, I'm not going to go through all the different settings, but I'm going to set it to what I'm using. Now here's where I'm changing some parameters. What I've seen most people do and what I've been doing since I've been playing with the MiniDSP was setting a house curve in here. I was setting up my target to be a slight rise in slope as the decibels go, or as the response goes lower, so that we have more bass boost, basically, lower in the registers. However, I got better results going for a flat line and applying my house curve as a simple shelf filter in MiniDSP. Here's what I do. So instead of having this checked, add room curve, and it's a similar looking screen in the non-beta version, but this is what I'm using here. We're just going to leave it flat. Now I do want to change low frequency cutoff to 0. And all that's going to do is keep this line flat in its usable range. I don't want any kind of dip down into the teens, because my subs do reach into the teens. And we want a 12 dB octave slope. Again, shouldn't make any difference, but if you are doing any kind of room curve, that's what you want to use. But that changing to 0 for the cutoff is the only important part for what we're doing here in this type of situation. So, target level. This is how high or low this target blue line is compared to the actual results we're getting from the subs. Now this is important because it's going to determine what the filters, what the EQ results are going to be. If I were to run this right now, it would say, hey, I want this sub level to be hugging this blue line. You need to boost here, boost here, boost here, boost here, all this kind of boost in the EQs to get it to match the blue line. Boost is not what we want whatsoever. So what we need to do is bring this down so that it's below our sub levels. And it can be 100% below, that really doesn't matter. But we want it below because now the EQ filters will be saying, okay, cut this, cut this, cut this. Cutting is far cleaner than trying to boost. So I'm gonna bring this down to somewhere in its lowest range. We're getting around here in the upper teens, somewhere around here. A little bit of a dip here, that's not a problem. This is simply the sub itself. The SVS subs have DSP that you can't turn off as far as its low and high pass filters. So that's always going to be there. These subs are not passive, so I'm never going to have a ruler flat line all the way to their lowest extension. That's just the way SVSs are. But we're down here right about where this level is, so that's okay. Now what we want to do is come down to filter tasks. That's basically what do you want to do. Now these two figures here, I've had a number of people contact me saying, no, those should be 0. This is individual max boost and overall max boost. This is saying if your EQs are trying to boost, how much do you want to allow them to boost? Well, we're not boosting, so it's irrelevant. I could set these to 0, I can set them to what they are now, which is the max, or anywhere in between, and it shouldn't make a difference. But if you are boosting, these do come into play. I have them maxed out simply to eliminate that as any kind of bottleneck variable. If for some reason there's a weird filter result that it does want to boost a little bit, I don't want it to be gimped by these being 0. That's it. This is not saying it's going to boost by 18 or it's going to boost by 12. It's just saying if you need to, that's the max you can go to. That's it. So match range, this is, I want to set it between 20 and 80. 80 is my cutoff. Set this upper to whatever your cutoff is. Most people are probably going to be 80. This is saying between what parts of this do you want the EQs to be working? So for example, I don't want it to be working down to 10 because really what's down here in the teens down to 10 is just how the subs are responding in the room. I can't do anything to this signal. It is what it is. I don't want to do anything above my crossover point, like 90 or 100, because that isn't being controlled either. That's being rolled off by the AVR. So what I'm looking to do is just control what's between 80 and 20. You could go 30. Depends on the sub you have, how low it goes. Mine are going into the teens, so setting a little bit above that at 20 works perfectly. You can play around with that a little bit and see what works best for you. And flatness target, that's how tight you want the results to try and hug this line. Set it to 1. That's simply the best it could possibly be. There's no reason to shoot low. Air Force, aim high. So now we just click match response to target, and it's giving you a warning that, hey, your actual result is far above the line here. You sure? Yes, that's what we want. We want it to cut, not boost. And now it'll go ahead and try to match that line and give you some results. Don't worry, these results are just predicted. They do not specifically match what happens in the room. And to verify the results, all you do is run another test. But first we have to click down here, save filter coefficients to file. And what this does is make a text file that the MiniDSP can then read. And you just give it a name, and save it someplace familiar. So this is going into my documents folder. I've already got it done here, and I called it new one flat. I also had, I was playing around with different house curves and all that kind of good stuff. And here's where I found out that going for flat gave me better overall results. So let me load those now. Now what you see here is a test of both of my mains run separately. You have to unplug one at a time, turn off the subs or mute them in MiniDSP, and just measure each main separately. And that's what we've got here. So they're both just about even as far as in-room response and all that kind of good stuff. Neither one is perfect because no one speaker is going to be perfect in a room, but together they work. So here is, click that. Here's both mains together, and this is crossed over. And this is half of what we're going to be using for the new time alignment feature. Now I've seen some people using the individual left and right measurements and then using the average results and using that instead. I got better results from using the actual playing both mains at the same time result. So try it both ways. This is the way I did it, and it worked fine. Click over in the upper right on controls and then click alignment tool. Now what we're going to be using is that both mains and both subs runs. We're going to be comparing the two, and that one there and this one here. So this pulls both in, and you don't have to worry about all the details. Basically, this is going to run through an algorithm, and pretty much like it does for the EQ correction, correct for phase. All we have to do is find our crossover point and click on it. So I'm crossed over at 80. We're going to click on 80, and then we're going to click Align Phase Slopes at Cursor. So that's going to say align the mains and the two subs, whatever you named your runs, at your crossover point. And boom, we get this nice little result down here. Now it gives you it in delay, negative 19.12, or it gives you it in feet, 21.6 or so. And here is the cool part. All you have to do is plug those in. If you're doing it in MiniDSP, this is a delay that you're going to be putting in. Now it gives you it on the mains channel. All you have to do is swap negative for positive and apply it up to the subs. So for example, it wants you to give a negative delay to the mains. Well, we're going to give a positive delay to the subs. So it wants a, say, negative 19 delay. We want to add a 19 delay in MiniDSP to our outputs right here. So we would put 19 in both of these slots. And again, if you have an offset, keep that. So if you had a 2 dB offset, one would be 19, one would be 21. You get the idea. Or you can do like I did and just do it in the AVR. You only have to do one setting. So it says 21 feet, 6 inches, so 21 and a half feet. You just go into your AVR, go into your distance, go to your sub, and add that to whatever number you are at. Mine came out to 35.2, adding the 21.6 to whatever arbitrary number I was at for testing. And you're done. And I did verify through a lot of trial and error testing right around those results that that was dead nuts on. It's that simple. So it takes all the trial and error out of getting your phase and the trial and error out of your EQs. This is literally a 45 to 60 minute process from start to finish once you've physically placed your subs and speakers. Really is a fantastic result. Then the other cool thing that I did was, instead of, like I said, putting a house curve inside the PEQ settings, normally you would apply it here on the outputs and you would have a house curve and it would be sloped up to give you a bass boost. I went for the straight, and then what I did is on the input, click the PEQ and applied a simple shelf filter. Now I found that a frequency of 50, a gain of, this is to personal taste, Could be anywhere from 1 to 20, whatever you want to boost by. And a Q of 0.7 will give a very nice slope from about 80 to 30, and then it starts flattening out from there. It works absolutely beautifully. So let me show you the end result of applying everything with my shelf as my house curve. So here are the results with a flat PEQ and a shelf FIR filter applied. Now I'm just going to boost the overall volumes back up in the subs themselves. And this is personal preference. I'm looking for a 10 to 15 dB boost between the mains and the bottom end of the subs. And that'll do it. So let's look at the full range here just to look and quickly see what the charts look like. I'll apply a little bit of smoothing so we can better see. And there we go. Obviously that's an extreme boost. You can play around with it however you like. But the point is, in the crossover region, it's perfectly smooth. If you look at 80, look at that. Just a nice, very smooth, tight hugging slope. Again, it's going between 30 and 80. That's absolutely perfect. Beyond that is personal taste. Hope it helps somebody. See you next time.